Good morning, students. We'll continue the previous class. In that previous class, we were discussing about the refractive index. It's a property of any optical medium which is going to tell the speed of light in that medium with respect to another medium. So, after seeing that refractive index, so there are two words: absolute refractive index. What mean absolute refractive index? It telling us the ratio of speed of light in air or vacuum to the speed of light in any other given medium. What it telling? The ratio of speed of light in air or vacuum to the speed of light in any other given medium. Means what? Here you comparing the speed of light in air with the speed of light in any other given medium. In previous class I said small c symbol we using to represent the speed of light in vacuum or air. Then small v symbol we have to use to represent the speed of light in any other medium, in any given medium other than air medium. You just look here, absolute refractive index that we are going to represent with the symbol small n, that is equal to c by v. Here c is the speed of light in air or vacuum. To the v means what? Speed of light in any given medium. What mean absolute refractive index? It's just the ratio of speed of light in air or vacuum to the speed of light in any given medium. See, after that, one more is that relative refractive index. Relative word only telling, it is going to compare relative refractive index. It is the ratio of speed of light in one medium to the speed of light in another medium other than air medium. What it mean? When we talking about refractive index, we need two medium because light ray has to come from one medium and it has to enter into another medium. There we observing what happening to their speed is going to increase or is going to decrease. That we called as a refractive index. So now you see here we need two medium. If these two mediums are other than air or vacuum, then we call that index as a relative refractive index. Relative. When you are talking about relative refractive index, those two mediums should be other than air medium. Example, if light ray is moving from water to glass, here water there, from water light is coming and it entering into glass. Here in this case you will be seeing what is the speed of light in that glass with respect to water medium. How much it was in water, how much it becomes when light entered into that glass medium. Now this refractive index you call as a relative refractive index because here these two mediums are other than air medium. If air is there among those two, if one medium is air, then you call it as absolute refractive index. If those two mediums are other than air, then you call it as a relative refractive index. Have you understood these two? You see here their formula, how I have written NR, that R, small r, subscript telling us refractive relative refractive index, that is equal to V1 by V2. What V1? V1 is the speed of light in one medium. V2 is speed of light in another medium. You just comparing what is the speed of that light in that second medium with respect to first medium. Here only I will tell how we have to write. N1, here I was saying in Snell's law, N21, what it means exactly, N12, what it means exactly, I will tell. Just look on this, just try to understand these refractive indexes. So now you see here, what mean N12, what mean N21. See, look on this first node point. On this first node point, see, light ray is coming from this rarer medium and entering into this denser medium. Just you call refractive index of this rarer medium as N1. I mean N1 mean what? N1 is telling speed of light in this medium. It may be anyone. It may water, it may itself glass, it may air, anything. What this N1 telling? Speed of light in that medium. Okay, now you come here. Light ray entered into this second medium. When light entered into different medium, obviously there is a change in its speed. At that time, in that medium, that light being with its own value, light ray being with its own one value for that speed. So that N2, here you take N2. This N2 telling the speed of light in that second medium. Getting? N1 speed of light in first medium. N2 speed of light in second medium. So now individually you observed N1 belongs to first medium, N2 belongs to second medium. When you going with comparison you may write like this type. N21. What? N21. The speed of light, you see here those subscripts, there you will be getting 2-1 or 1-2. Focus on first one, that is 2. N21 means it is the speed of light in that first mentioned word. Look, speed of light in that first mentioned number with respect to secondly mentioned number. Getting what I mean? See here, now N21 means speed of light in second medium with respect to first medium. If it is like this type, N12 speed of light in first medium with respect to second medium. You comparing what it means. Look here, what is this? See, light entered from first medium to second medium here. When it got entered here, their speed got changed. What you saying? N2 telling only the speed of light in that medium. N21 telling the speed relation between the speed of this second medium with that first medium. Just I will tell you, you see here, suppose just I will take numbers. Speed of light in this N1 number, here it is 4 number only, meter per second, you just leave that unit 4. Now you concentrate, it moving from rarer to denser. Obviously when it entered here in this one, speed going to decrease, that we discussed. Now speed of light in this N2 medium is less than 4. So take 2, this 2, This 2 is the speed of light in denser medium. This 4 is the speed of light in rarer medium. They are individual values. Now what about n21? How you write n21? You see here now. n21. You mean you can write that n21 as n2 by n1. n2 by n1 you can write. So now you see here. n2 value how much? Speed of light in that second medium is 2. 2 divided by n1. Speed of light in first medium is 4. 2 by 4. How much you will be getting that one? You will be getting it as 0.5. What this 0.5 is telling? See, n21 means n2 by n1. Their individual, respective value taken there, and you got that value as n21 is 0.5. Means what? What this 0.5 telling? See here, n21. The speed of light in that second medium with respect to one medium is equal to 0.5. Means what? 0.5 of that comparison. How much there in first medium? Here in this one it got decreased. How much it got decreased? 0.5 got decreased. 0.5 means what? Half. Half amount it got decreased. Was 4 here. When it entered in this second denser medium, their speed got decreased by half. Was 4, half reduced means it should be 2. That's why it is 2 here. Getting what I mean to say? Say that number, what you say here, 0.5. 0.5 is the refractive index of this second denser medium with respect to first rarer medium. I mean, what you say, this 0.5, what you conclude here, the speed of light in this denser medium got decreased by 0.5, decreased by half of the speed of light in rarer medium. For example, we saying that the refractive index of glass with respect to air is 1.5 we say, and the refractive index of water with respect to air we saying as 1.33. What these values indicating? What these values are telling exactly? See, refractive index of glass with respect to air is 1.5. What this 1.5 is telling? See here. When light is coming from air and entering into glass, here two medium, air and glass, speed of light in air or vacuum is 3 into 10 to the power of 8 meter per second. Speed of light in air is this much value. Now in this air, light is coming with that speed and entering into glass. Here glass slab there. Yes, it entered into that glass slab with that speed. When light entered into that glass slab, their speed going to get a decrease because of its more density. Because it is denser medium. We discussed why that speed is going to decrease. Yes, it got a decrease. Here we saying the Ri of glass is 1.5. What it is? It means the speed of light in this glass got decreased 1.5 times which it has in that air medium. I mean, the speed of light in that glass got decreased by 1.5 times as it has in air medium. Means how much it has in air medium, there 1.5 times got decreased in that glass medium. 3 into 10 to the power of 8 there, no? There 1.5 got decreased. Are you getting what I mean to say? That number indicating that much got decreased. 1.33 for water. When light is coming from air to water, now water is there. Light coming from air entering into water. When it entered into water, then also its speed going to decrease because of its more density, because of more molecules, light losing their energy. More molecules, they absorbing that light energy and re-emitting, and for that absorption and re-emission they taking some time. Because of this, their speed is going to decrease in that medium where more molecules are there. When you compare that water with air, in water molecules are more, so water is a denser medium compared to air. That's why when light from air entered into that water, its speed going to get decrease. How much with respect to that air? That is number 1.33. The speed of light in that water medium got decreased by 1.33 times as it has in that rarer medium, I mean in that air medium. How much it has in that air, I mean that 3 into 10 to the power of 8, there how much got decreased? 1.33 times got decreased. Similarly, you try to get it, it's very important. I take a few number here. Here it is 4, here it is 2. From 4 to 2. 2 is the value of speed of light in this medium. So now when you take in refractive index of this second medium with respect to this, you will be rating it as n21. I written here n21, that is equal to n2 by n1. n2 value, that is 2, by n1 value 4, 2 by 4, how much you got? 0.5. So now in this our present example, refractive index of this second medium with respect to first medium is 0.5. What this 0.5 telling? The speed of light in this denser medium got decreased by 0.5 times how much it has in this rarer, I mean in this rarer medium. Yes, you calculate that. 0.5 of this one, half of this one, 4 half, how much? 2. Yes, here that number is there. Have you understood what I mean to say? Just go with like this one, n21. Okay, suppose n12 means what? n12. n12 means refractive index, I mean of that first medium with respect to second medium. Now you comparing speed of light in that first medium with respect to second medium. This n12 we can write as n1 by n2, n1 by n2. Have you understood? This is about refractive index, a very important. Later we will be having numericals. While solving the numericals, we must and should know about what mean exactly the refractive index and how we have to use that one. If it is n21, you can write it as n2 by n1. If it is n12, you can write it as n1 by n2. This is about refractive index. Yes. After this one, see now we'll enter into some different phenomena. I mean property. What we discussed, refraction is one of the important property of light. Because of this property, some few phenomena, some few things existing in our nature, because of refraction of light. Because of refraction of light. For example, if you take a glass container and you put a coin inside that container. Take a glass container, empty glass container, and put a coin inside it and weave it normally like this, you will not notice any difference over there. I mean, the dimension, the size of that coin looks as usual when there is no water in that container. Yes, suppose in that container, if you pour the water, if you put the water to certain height, thereafter if you weave that same coin through the same container in presence of water, what you will notice? You will see some change in the position of that coin. Previously you were noticed that coin was at the bottom only. Now in presence of water, if you weave like this, that coin appears to came up. That coin looking like bit enlarged in its size. That coin looking like came up. This is because of refraction of light. So like this, many are there. Suppose one more example. In that same container only, when water is not there, if you put a pen, then you notice that pen looking like straight only. If you pour the water in it, what you will notice? You will notice that that pen looking like it has broken. That pen looking like it has broken. Upper part is being here and the somewhere lower part is looking like this. It bending towards the normal. What you see there, you will be seeing like that pen has broken. Really, in reality, that has not broken, but you feel it has broken. It looking like that, it is because of refraction of light. Many phenomena are there. So just we'll have a look here on this one phenomenon called as, you see here, refraction of light through a parallel sided glass slab. We call this as a lateral shift. They may ask a question on that. What mean lateral shift? Try to understand. What we are observing here, we are doing one experiment. Refraction of light through a parallel sided glass slab means what? You will be taking one glass slab like this type of rectangular sheet, rectangular body. Okay. A rectangular shape glass slab you will be taking. Rectangular shape means it being with some parallel sides. Here one side is there, here one. These two are parallel sides. Okay. It looks like a rectangular. I mean, it is a cubical body. These two are parallel. These two parallel in front and back. So like that. Now just look here. We're thinking about sides. Side, I mean parallel sides, these sides, this one and this one. So now here it's a diagram of that parallel sided glass slab. This is a parallel sided glass slab and this glass we taken as a medium 2. This is medium 2. I said when we are talking about refraction we need two medium. Light should come from one medium and has to enter into another medium. Here this glass we taken as medium 2 and this glass should be surrounded by a homogeneous medium. Why it must and should be surrounded by a homogeneous medium? I said what mean homogeneous? Homogeneous medium means in that medium the concentration of molecules throughout its entire volume should remain same. Means the speed of light in that particular homogeneous medium should remain same. That keeps that rectilinear propagation in that medium because of its same property everywhere. That's why it should be surrounded by a homogeneous medium. See here, white should be surrounded by homogeneous medium. Later I will give conclusion for that. That is very important. Just you look around this glass slab. Around this glass slab, a medium there that we named as medium 1, air. Air medium is there. Around this glass slab, air is there. Air with same concentration of molecules. Air is there. Now look here. That we named as medium 1, glass as medium 2. Now you look here. This light ray, concentrate on this light ray. This is a light which is coming and going to strike that glass slab on this face, this side face. This light is coming like this. It got incident here. Yes. When light going to hit any surface, it may reflecting while discussing reflection. It may transparent while discussing refraction. When light strikes that surface, immediately what you have to do? Immediately you must and should draw one perpendicular line to that surface. Perpendicular line to that point of incidence. So now you see here, this is your point of incidence. To this point of incidence, we should draw a perpendicular line. You see this one, this blue colored dotted line indicating perpendicular to this point of incidence. That perpendicular line we have to call as normal. Very important. This is normal. Yes, you extend it. It is normal to that point in first medium. It is normal this side. Normal to that point in that denser medium. Extend it like this. You see, this is normal to this point. See now, when light got incident here, look, light ray coming from which medium? Air medium. It is coming from air and glass there. Among these two, air is rarer and glass is denser. Glass is denser because in that molecules are packed tightly. So the speed in that glass is going to decrease. So we call it as denser. Now light ray is moving from rarer medium to denser medium. When light moving from rarer to denser, it is going to bend towards the normal in that denser medium. That is very important. This is incident light. It got incident here. Now it is moving in that glass. Instead of moving straight, instead of moving along this initial direction, that light ray changing their direction, it bending inward. Why? That light ray is bending inward, I mean it has to bend towards the normal. This is normal. Getting what I mean to say? Yes, rarer to denser, it should bend towards the normal. Instead of going like this, it bent, I mean it moved in this line. I mean this much it got deviated. Here I mentioned delta 1. Delta 1 indicating deviation suffered by the light due to the refraction by first surface. Instead of going straight, it bent by this angle, delta 1, angle of deviation at first side surface. Here I1 is angle of incidence on this first surface. Getting what I mean to say? This right now, this light ray bent towards the normal and it keeps moving along this line. It keeps moving along this line. Now this line, suppose I just am going to name for your idea. Suppose you see this is A, this is B, and this is C, and this one is D. See here. AB is incident light ray for this surface. You name it as surface 1 and this one as surface 2. Okay. For this surface 1, AB is incident light ray. What about BC? BC is refracted light.